At some point, I just need to accept that I like making videos about things that cause me pain. In this case, we have a boxed copy of Sun Solaris 7, which at $60 wasn't something I was going to pass up. Now, as far as Unix systems go, both Sun Microsystems and Solaris have a rather interesting reputation of being both a great source of joy and a great source of misery. I am almost certain that my comment section from this video is going to run the full gauntlet of hell yes, Solaris, and oh god, why, and everything in between. To say opinions on Solaris are polarizing is like saying water is wet. It just kinda goes without saying. As usual, this is your host NCommander, and today we'll be sipping some fine coffee as we dig into the legacy of a more enlightened age. Let's start by taking it from the top by getting everything unboxed. I'd love to make a big show of this, but honestly, the entire package is a bit underwhelming. Besides the usual stack of documentation and a binder of CDs, there isn't that much to actually show here. The only real thing that was semi-unexpected were the two packed-in demos labeled Sun Workshop and Sun Enterprise SysMON. I'll put these aside for now, but on the whole, it appears that Sun was very much a no-frills company, at least with its physical media. Still, everything will be fine when I get the SPARCStation out, and oh, well, that might be a problem. So, at the time of this recording, I don't actually have any SPARC hardware. Now, some of you might think that I'll have to resort to using the boring Intel edition, but as it turns out, those mad lads at the QEMU project not only have added SPARC emulation, they note that Solaris 7 works. So, from this point forward, we're going with an emulated SPARCStation 5, since how could that possibly go wrong for me? Tempting fate aside, setting up QEMU turned out to be relatively straightforward. One thing of note is that the version of QEMU provided with Ubuntu 2020 keeps getting stuck in a boot loop. To actually make any sort of progress, I had to compile qemu-6 from scratch. I also had to set up a tap network to allow Solaris to be able to talk to the rest of my LAN. For reasons that will become clear, the built-in NAT networking won't fly. With everything set up, it's time to flip the switch. After a few seconds, we're thrown into OpenBIOS and the iconic 0 prompt. With the Solaris 7 disk in the drive, it's just a matter of boot cd-rom:\d, and away we go. We get the usual SunOS banner followed by a Solaris splash screen. After a bit of waiting, we're thrown into a graphical installer. We're quickly prompted to select a locale and then enter networking information. However, it doesn't take too long to bring us to this mandatory prompt to set up named system services, with the choices being horrific, painful, and DNS. Since I really don't want to dive into the world of NIS or NIS Plus for this video, I went with the seemingly simple option. However, after entering all the necessary information, the install would not allow me to proceed, citing that it couldn't find an address entry. By using Wireshark, I could see that the VM was indeed trying to look up its own hostname via DNS. It might be superstition at work, but I vaguely remember that old versions of Solaris were prone to hanging if it could not properly resolve its own name. As such, this was something I wanted to fix properly. After debating various options in my head, I decided that the easiest way forward was to set up bind, create an ncommander.lan domain name, and properly set the forward and reverse records. After doing so, the installer was happy to proceed. Returning back to the matter of installation, after resolving the network issues, the install process ran for a while and then suddenly died with unrecoverable error relating to the hard drive. From the console log, we can see that it tried to enumerate the hard drive and then failed miserably. We also now have a command line in which to try and address this. Once again, this failure was somewhat expected, in this case due to the entirely blank hard drive image. Solaris uses a header written to the disk known as a disk label to perform identification and initialization. Disk labels are something common to many Unix operating systems and can best be described as device-independent partition tables, and are in fact still used by modern BSD operating systems today. In theory, this should be a relatively easy fix, but it's not quite that simple. Solaris provides the format command for creating and initializing disk labels. Running format does show the proper device tree entry for our emulated hard drive, but attempts to auto-detect the settings error out. I suspect that this is due to limitations in QEMU, either in its open firmware implementation or in its SCSI controller emulation. I admittedly got stuck here for a while, but fortunately, I was eventually able to dig up an article on Virtually Fun which properly documents the disk geometry of a 36GB drive. After a few attempts, I was able to successfully use the format utility to write a known good disk label. However, attempts at performing a sector-level format failed. This is, once again, likely a QEMU limitation. Despite that failure, upon a reboot, the installer seems happy with our newly labeled hard disk, and we are thrown to the main screen of the installer. Or if I'm being specific, it's the main screen of the traditional installer. In truth, there are two separate ways to install Solaris 7, one being the classic installer that we've been using, and one being the wonderfully 90s Solaris WebStart. WebStart is such a wonderfully weird beast that I think it's worth a segue to document it, but let me run quickly through the basic installer, which was a mainstay through the early Solaris years. In truth, there's not a lot to say about this. The installer has a mostly sane set of defaults and provides prompts if you wish to customize one or more aspects. It's not the most intuitive of UIs ever designed, but it's a league better than what I was putting up with in Debian 2.1, and it's also consistent in its behavior from start to finish. The only thing I felt that was necessary to change was in the disk label partitioning. As with most Unix operating systems, the file system is split into multiple mount points. With a minimum configuration, this leads to a root partition, the export home partition, and the swap space. Under normal circumstances, this is a reasonable setup, but the Solaris installer leaves virtually no free space on the root partition. This is likely due to the expectation that applications would be provided over a combination of NIS and NFS. It's impossible to delete the slice for export home, but I gave the root partition a few extra gigabytes of space for add-on software and then carried on. From this point, the installation continued on without my input. None of the supplemental disks are used in this type of installation, and I was eventually kicked to a command line to finish any manual configuration needed. After rebooting, I had to answer a few final questions, set the root password, and then I was finally kicked to DT login. At this point, I could just sign in, but let's take a step back and look at WebStart, since it's the pinnacle of 90s design to install an operating system with a Java applet. Yes, you heard that right, an applet. WebStart definitely appears to be a work in progress. As the documentation shows, it can only be used for fresh installations, and it has to be explicitly invoked with the browser argument added to the boot command line. At first, nothing appears to change since we get the same prompts relating to locale and name servers, but then suddenly a wild web browser appears. This is HotJava, Sun's own web browser for Java applets ran in Java, and let me tell you, it's a giant pile of donkey dingus. While Java would eventually become a well-known pillar of enterprise development, its early years could be best summed up as pain. This is especially evident here since HotJava is both very slow and has a lag that unfortunately does not show up well on camera. One thing of note is that Sun appears to have modeled their design look and feel around Microsoft's UI guidelines of the time. Almost all the installation steps, such as partitioning, are handled with a wizard-style UI, which was typical in Windows programs of this time period. These wizards get the job done, but they feel very out of place as compared to the rest of the system. Besides the updated look and feel, the main difference between the traditional Solaris installer and WebStart is that WebStart allows you to automatically install all the bundled applications in one go. This includes things like AnswerBook, Netscape Communicator, OpenGL support, and more. After going through all the prompts, we're left with just a text box indicating installation progress. After waiting about half an hour, the system suddenly rebooted and I was presented with one of the uglier UIs that I have ever encountered in commercial software. This is the secondary part of the WebStart installation, and we are now prompted to change disks. This was far more annoying than it needed to be, since the disk prompts don't match the physical printing on the CD-ROMs. After quite a bit of trial and error, I eventually got through this process and was prompted to reboot. This brings us back to the present with the DT login screen. At this point, we can log in as root and then continue to set up the system. Immediately after typing in the username and password, we get this prompt to choose between the then new common desktop environment and open Windows. I'll go with CDE for now since I'm partial to Motif, but we'll take a look at open Windows before the end. After a bit of waiting, we're thrusted into the 3D chiseled goodness that is Motif and CDE. At this point, we still need to do some configuration. For one, while the system's IP address and name servers were set during installation, there wasn't a prompt to enter a default gateway. That's easy enough to resolve by writing the router's IP address to ect default router and then using the route command. After doing so, I could use the ping command and even log into a remote bulletin board system to confirm that I had full connectivity. With that taken care of, it's time to make a non-root user. To do so, I can load up Admin Tool, which is Solaris's graphical administration utility, which, among other things, can create new users and groups. Admin Tool itself is not what I call a powerhouse, and it leaves a lot to be desired as compared to AIX's SMIDI or even Linux tools of the era such as EAST or LinuxConf. Still, it does get the job done, although there are a few things to note here. First, Solaris usernames and passwords are limited to 8 characters. Secondly, the user's home folder is under export home and not the more common home directory. This is a unique Solarisism that I think is worth talking about. Solaris does have a home directory, but any attempt to write in it errors out. This is because the system home folder by default is reserved for NFS auto mounting and remote users. In 1999, the standard mechanism for handling NFS auto mounting was through the Network Information Service, or NIS. NIS handled the synchronization of users, groups, and more in a manner very similar to NT domains of the era. The idea is that your data is stored in export home on a central server and then would be auto-mounted over NFS as needed. This was considered good practice for Solaris installations at the time and provide what we would call a roaming profile in modern terms, but it was very much a mixed bag in practice. In theory, when everything worked, a user could sign in at any terminal on a Sun network and everything would be the same. In practice, this functionality required that hostname resolution, NIS, and NFS to work flawlessly, which, due to design flaws, it rarely did. While I have already talked about the hostname resolution problems earlier, NFS introduced another pain point into the equation. While NFS is essentially a standard in all Unix operating systems, its early implementations were fraught with problems. In real-world scenarios, due to issues on how lock files were implemented and design decisions relating to how the port map daemon works meant that NFS suffers from poor performance and risk deadlocking due to a daemon crash. These issues, and many more like it, while not entirely unique to Solaris, were so bad that an entire chapter was dedicated to NFS's shortcomings in the Unix Haters book. Sun would eventually rework Solaris, the NFS protocol, and even NIS in an attempt to eliminate these issues. But this vision of user mobility never worked anywhere as much as Sun would have hoped. I may explore NIS and NFS in a later video, but the short version is that LDAP and Kivaros would eventually displace both the legacy NIS protocol as well as its successor NIS+. As for NFS, Well, it would be dramatically reworked in version 4 to solve many of the long-standing legacy issues that had plagued the protocol through the 90s. I do hope that this sheds some light on what I suspect was a minor mystery for quite a few Solaris users back in the day. At this point though, we're ready to log in as non-root, but before doing so, I think it's a good time to look at the last two CDs that were in the box. The first is a demo of Sun Workshop 5, which was Sun's fancy name for their development tools. And yes, I do mean demo. As compared to Solaris, Workshop has a surprisingly complex licensing scheme and integrated DRM in the form of FlexLM. While it is possible to install without a license file, CC simply errors out and I was unable to track down a way to bypass this. This left me somewhat up a creek, but surprisingly, I still have a paddle. In truth, it was fairly standard practice to make development tools an extra and expensive add-on, which had a fairly universal solution. That is to say, most people just installed GCC. This also had the added bonus that your C compiler might actually conform to standards. And yes, HP Unix, I am looking right at you. I figure that documenting the fine tradition of setting up GCC is worth another segue, especially since I found a precompiled version for Solaris 7. In fact, there's an entire set of compiler packages that are still maintained called tgcware for Solaris 2.6 and later, complete with build scripts. Personally, I really have to appreciate the dedication of maintaining a toolchain for an operating system that is old enough to drink. However, this is an NCommander special, and thus it probably goes without saying that this wasn't the compiler salvation that I was hoping for. To put it bluntly, the installation process was not very straightforward, but the true insult to injury was that every binary errored out with a symbol error. This cryptic error is Solaris's way of telling me that my System C library is older than what tgcware expects. This appears to be due to the fact that I am missing updates from Sun, but unfortunately I couldn't find any mirrors of the older Solaris patch sets. Or, well, to be more exact, I didn't find them when I originally recorded this segment. I admit I was pretty close to throwing in the towel when I spotted this note on the tgcware website that said that I could apparently use the Solaris 2.6 compiler as a last resort. After downloading the necessary files and fiddling with package add for a while, I'm surprised to report that yes, I have a working C compiler, and yes, I was able to build Hello World. That being said, I am not entirely sure that everything is happy. Just as a test, I did try to compile NetHack 3.4.3, but I ran into several issues with the header files. With some handholding, I did manage to get NetHack to build, but I suspect that I would really need to rebuild GCC4 from source and its magical fix include script to have a fully behaving compiler. Still, the fact that I have a working compiler at all is definitely a victory. After all, my only alternative would be to build a Linux to Solaris cross-compiler and then cross-compiling GCC itself over to Solaris 7. And let's be honest, it's not like that's something I'm crazy enough to do, right? Before we get into a deeper debate on the state of my sanity, we still have one more CD to look at. That CD is Sun's Enterprise SyMON, which, as the name suggests, is a network and system monitoring tool. Essentially, SyMON provides detailed telemetry data for all hosts on a network, either with its own agent or via industry standard protocols like SNMP. From the manual, I get the impression that this is Sun's take on cloning Microsoft's system management service, but if it is, it feels woefully inadequate. Right off the bat, there's an immediate problem that the entire thing runs slower than molasses in winter. I think part of this is due to the fact that the entire UI is written in Java, which, with this version of the JRE, is an exercise in frustration to use. Even after I got both the server and agent working, the entire thing is remarkably underwhelming. While I can see basic system information, it doesn't appear to provide any true management or reconfiguration abilities. As far as I can tell, it really does appear limited to just monitoring and alerting. Well, that and ripping off the Windows 95 Explorer icons. I'd have to set up a full network to evaluate SyMON properly, but I am staggered on how bad the out-of-the-box experience has been. If anyone's got experience with SyMON, let me know below, as I'd love to hear your experiences. With all those tangents aside, I think at this point it's time to log in as a normal user and poke around the system a bit more. Upon doing so, we immediately get blasted by this pop-up for Sun user registration. I suppose it should be expected since it was the 90s and everything wanted you to register everything. After closing Hot Java, I found myself with a bit of a stumbling block. While there are a fair number of bundled applications, in truth, they aren't a great representation of Solaris as a whole. Instead, the main reason that people used Sun hardware and software was due to the value that the platform had instead of any singular app. Solaris provided a stable environment with both then cutting-edge technologies and an excellent level of backwards compatibility. We saw parts of this earlier with GCC, but let's take a bit of a closer look. For example, I was able to load a commercial version of FrameMaker from 1994, as well as a copy of WordPerfect for Unix from 1995 without issue. This is in stark contrast to Linux, where binary compatibility was, and to an extent still is, something of a pipe dream to this day. We can also see this with the Open Windows environment, which I spoke about a bit earlier. At first glance, it just seems to be another desktop environment, but there's more here than meets the eye. In truth, Open Windows and its underlying OpenLook components, as well as the XView library, were Sun's attempt at streamlining X11 programming in 1988. While Sun would eventually abandon these efforts in favor of Motif, many of these components were released as free and open source software. In fact, application support for Open Windows applications officially lasted until Solaris 10, which was released in 2005 and is still supported until 2024. That is an impressively long life, to say the least. I'm fairly certain that we'll be exploring more of Sun's legacies in future videos and perhaps take a dive into its spiritual successor, Illumos. I already know that we'll be revisiting Solaris when I make a video on Internet Explorer for Unix, and yes, that was in fact a real product. Perhaps I'll even go through the work to recreate this properly cursed screenshot that I took in 2012. Let me know in the comments if you want to see that sooner rather than later. It's on that note that if you enjoyed this video, please give it a like and consider subscribing. If you really enjoyed this video, consider hitting that bell or becoming a Patreon. As always, you can follow my adventures in real time on Twitter or come hang out on Discord. Until next time, this is your host NCommander signing out and wishing you all a pleasant day.